Section 4.1, Exponential Functions, Exponential Functions, Part 2. Okay, last time we looked at basic graphs of exponential functions. We're going to again expand on that with transformations. Okay, f of x is equal to 2 to the x power. F of x, or y, is equal to 2 to the x. What is our base? Base is 2 greater than 1, so we have an increasing graph. If I plug in an x coordinate of, say, 0, 2 to the 0 is going to equal 1. So this graph is going to increase, and go through the point 0, 1. That's going to be graph number 3. F of x is equal to 2 to the x power. Okay, so let's see how we can work with part B. Part B says 2 to the negative x power. Okay, f of x, or y, is equal to 2 to the negative x. When we see a negative in the exponent, what that does is flip this fraction. This is actually 1/2 to the x power. What's our base? Base is 1/2, which is a fraction. And if we remember from basic exponential graphs, fractions as a base tell us our graph decreases. If we plug in x is equal to 0, we're going to have 1/2 to the 0 power, which is 1. And so we want to look for a graph that decreases and goes through the point 0, 1. Okay, that's going to be graph 1. It decreases. Our graph decreases and goes through the point 0, 1. So this must be f of x is equal to 2 to the negative x. Okay, let's look at, that was part A and B. Let's now look at part C. Okay, what does part C say? Part C is f of x, or y, those are the same things, negative 2 to the x power. We're going to take this 2 to the x graph and we're going to do a transformation on it. Multiplying on the outside of a function by a negative, flipped it on an axis. Which axes do we flip? We flip on the x-axis. So if I take this 2 to the x graph, we're going to take 2 to the x, and if I flip it on the x-axis, we see something that looks like this, and that matches graph 2. So graph 2 must be f of x is equal to negative 2 to the x. Okay, in a similar fashion, let's look at part D. If we look at part D, f of x, or y, is equal to negative 2 to the negative x, which is negative 1/2 to the x power. We're going to take our 1/2 to the x graph and we're going to flip it on the x-axis. Okay, so where's our 1/2 to the x power? That's here. 2 to the negative x, or 1/2 to the x power. If we were to flip that on the x-axis, we would get a graph that looks like this. And notice that matches part 4. And so part 4, not by elimination, we want to make sure we understand our graphs. This is going to be negative 2 to the negative x, which is the same as a negative 1/2 to the x power. This negative takes this 2 and, remember, puts it in the bottom. Okay, graphing exponential functions by looking at a basic graph along with some introductions with transformations. Okay, let's look at this problem here. For this problem here, we want to find the exponential function whose graph is given. Okay, so we see our graph is decreasing. We see that if x is equal to -3, y is equal to 8. Let's see if we could use that information with our exponential function. Y is equal to a to the x power. Y is 8 when x is -3. Okay, what does this negative in the exponent do? It's going to send a to the denominator, making 3 as an exponent positive. I'm going to do a quick cross multiply. So then we have a cubed is equal to 1 over 8. What do I cube in order to get 1/8? What do we cube in order to get 1/8? Yep, we cube 1/2. So that's our base, 1/2. Okay, so we have f of x is equal to base 1/2 to the x power. Or an alternate form that we want to be able to go back and forth between the two would be 2 to the -x. Okay. Graph the functions not by plotting points, but by starting from a basic graph, a graph in figure 2. A graph in figure 2 was the one where we had increasing and we had decreasing, okay? So those are our graphs in figure 2. Graph the function not by plotting points, but knowing if our graph is increasing or decreasing, looking at a transformation. After we do that, we're going to state domain, range, and asymptote. Okay, here we go. What's the base? Base is 2 greater than 1, so our graph increases. Now, if this were 2 to the x minus 3, what transformation would we have? That would move us down 3. But that's not what we were given. We were given x minus 3 in the exponent. Okay, so if this meant down 3, what do you remember that this meant for transformations? That meant right 3 units. Okay, so let's get a graph. Our basic graph is going to be considered 2 to the x, not this one, because that would be a base of a fraction. Here's the graph that we would be looking at. We know that it goes through 0, 1. If we plugged 1 into 2 to the x, we would get 2 to the first, which is 2. If we plug in 2 to the 2 squared would be 4. We know its basic shape. This would be the graph of 2 to the x. Okay, so what we're going to do is we're going to take 2 to the x and we're going to move it right 3, and that would give us our new graph. Okay, so let's get a couple more points here. 3, 4, 5, say 6. Okay, we're going to take our graph and we're going to move it right 3. Okay, 1, 2, right 3. 1, 2, right 3. 1, 2, right 3. So if we needed to, we could call this 5, 4. We took our graph and moved it right 3 units. Here would be our graph, 2 to the x minus 3. Okay, so we graphed our function. Now we are ready for the domain, range, and asymptote. Okay, let's look at our domain. Automatic, negative to positive infinity. That was from part 1. Range, if I look at my y values are going to approach the x-axis but never touch or cross it. So our range is going to go 0 to infinity. And then the asymptote is the x-axis. So we'll do ASMY or something like that. Our asymptote is y is equal to 0. Or if you want to write x-axis, that's the same thing. Okay, that's the end of part 2.